This video is about the half-angle identities found in section 6.3. Okay, first of all, here is the sign of half an angle. This comes from actually the sign of a double angle formula that's just kind of flip-flopped around a little bit. I'm going to skip the proof, so here is just the identity. So if you're trying to find the sign of half of an angle, what you'll be using is the cosine of the full angle to work it out. It'll either be the positive or the negative square root of this expression, right? It's not both of them. You have to pick one, and the formula or the identity just on its own won't tell you. It'll boil down to what quadrant the half angle is in. We'll come back to that more specifically later. This is the formula for cosine of half an angle. It looks very much like this sign formula. The difference is there's a plus sign here in the numerator. Here there's a minus sign. Now for tangent of half an angle, there's actually three different versions. One is basically if you took the sine and divided by the cosine. However, you can come up with a couple other versions. Here's one of them, the sine of half of an angle. It uses the sine of the full angle divided by 1 plus the cosine of the full angle. And then also, there's this one here. I think this one often is the easiest one. It doesn't have any square root, and the denominator has just one term, which is often easier to work with. Okay, let's look at a specific example. If this is the same kind of problem we've been doing with the sum and difference identities and with the double angle, now it's going to be with the half angle. A lot of the same kind of strategies. All right, so here's the question. If the cosine of x is equal to -3/5 and pi is less than x, which is less than 3 pi over 2, find the exact value of the sine of x divided by 2. Okay, so we're trying to find the exact value of the sine of half of an angle. So here's the formula that we will work with. Now, the tricky part is often the plus or minus. You have to choose one of them. It's not going to be both. Okay, so here's what you need to ask yourself. What quadrant is x divided by 2 in? Right? Because the question is all about finding the sine of x divided by 2. So if you know the quadrant of x divided by 2, then you can figure out, well, the sine of that angle, whether it should be positive or negative. All right? So figure out what quadrant x over 2 is in, and then ask yourself, does an angle in that quadrant have a positive or a negative sine value? Okay, so it didn't say that x over 2 was in quadrant whatever, okay? It says that x is between pi and 3 pi over 2. So that tells you what quadrant x is in, all right? But we need to know x over 2. So there's a little trick that you can do. Take this inequality and write it down. Pi is less than x, which is less than 3 pi over 2. Okay, so we know that to be true, and we're interested in x divided by 2. So if we divide x by 2, that's x divided by 2. So what we'll need to do to have another true inequality is to divide the left side and the right side by 2. All right, and do a little simplifying. So pi divided by 2 is pi over 2. That's less than x over 2, and that's less than, if you take 3 pi over 2 and divide it by 2, that's 3 pi over 4. Okay, so can you figure out what quadrant this is in? Yes, because we know for sure that pi over 2 is up here using the positive part of the x-axis. We know that pi is over here, and then 3 pi over 4 we know is right in the middle. 3 pi over 4. Okay, so if x over 2 is greater than pi over 2 and less than 3 pi over 4, then we know that it's somewhere in here. All right, so basically we know it's in quadrant 2. X over 2 is in quadrant 2. Okay, and what we're trying to do in our problem is find the sine of that angle. So the sine of an angle in quadrant 2, all the sine values are positive. So the sine of x over 2 is positive. So we're ready to use the formula, and it'll be the positive square root. Okay, so this is the formula that we'll use. I didn't put the plus because it'll automatically be positive if you don't put anything. Now, for this particular one, we will need to know the cosine of x, and that was actually in the given, what the cosine of x was, right? So we don't have to draw a reference triangle and figure it out. We can just substitute in negative 3/5 in place of the cosine of x. So we're going to have the square root 1 minus negative 3/5 divided by 2. Okay, now these are often a little tricky to work out. Just focus on what's underneath the square root to start. So we're looking at 1 subtracting a negative. So 1 plus 3/5. All right, so just working underneath 1 plus 3/5. We need to combine those so we could get a common denominator. So we're looking at 5/5 plus 3/5. So that's going to give us 8/5 divided by 2. Okay, so that is going to be 8/5 times 1/2. So divided by 2, I'm going to multiply by the reciprocal, and I can do a little bit of canceling here. So I'm going to end up with 4/5. All right, which is the same thing as the square root of 4 divided by the square root of 5. Okay. I need to rationalize the denominator because I'm at the very end. So I'm going to multiply by root 5 over root 5. And I also know that the square root of 4, that is just plain old 2. So for the final answer to this problem, I'm going to get 2 times the square root of 5 divided by 5.